All right, welcome. Today we're going to talk about covalent bonds and how to make covalent bond diagrams. This is going to be a quick one, if I can make it so. And then next up, I'll probably post another video on problems I can ask about how to actually work with covalent bond diagrams and what might show up on your test. So first one first. The two things you need to know about covalent bonds are electrons are shared. Now, this is specifically valence electrons, and the sharing is super important because that's one of the things that differentiates a covalent bond from an ionic bond. Remember, in ionic bonds, electrons are transferred, but here they're shared. The other thing we're looking at is this is usually between two or more nonmetals. So let's keep these two things in mind. And what I'm going to do is kind of make a step-by-step diagram on how to actively make covalent bond diagrams. So making covalent diagrams. Use a new color for this. Step one, we will just draw Lewis structures. You also know how to draw your Lewis structures now. Those are things with the element symbol and the valence electrons. That's it. Step two, we will identify lone electrons. Now, what the heck does that mean? Well, I'll show you. If we look at an example, we'll look at sulfur. Sulfur has 1, 2, 3, 4, 5, 6 valence electrons because it's in group 16. And the lone electrons are this one and that one right there. These guys are our lone electrons because as you can see, they are lone. Well, this one and this one are in a pair. So we've identified the lone electrons. Little caveat, this is important because lone electrons are what we use to make covalent bonds. So our lone electrons are what we use to make covalent bonds. And because of that, we can see that if you drew your sulfur the wrong way, where you put all the electrons in pairs, you would have 0 bonds. And that is why this is wrong. All right. Moving over to step 3. It's a little fun game of connect the dots. Step 3 is going to be connect lone electrons from different atoms with lines. Seems like a really dumb, simple step, but I'll show you exactly why we're doing it. The important caveat to step 3 is that each line represents one covalent bond. Got my T on covalent. And even further, each covalent bond is 2 shared electrons. So it's really important that we show our covalent bonds. All right, the 4th step, we are going to redraw Lewis structures. And we're going to keep a couple things in mind when we redraw Lewis structures. A, the atom with the most bonds is the central atom. So when we draw it, whichever atom has the most bonds, it's going to be in the center. B, second thing, we will replace the lines from step 3 with short, straight lines. This seems like a pretty arbitrary step that's hard to wrap your mind around, but once we start working these out, it'll kind of make sense. Finally, step C is we're going to add back electron pairs. So any pairs of electrons that you have, you're going to add them back. If we look at our example of sulfur with 1, 2, 3, 4, 5, 6, our electron pairs are just these little guys right here at the top and right side. They're what kind of is going to stick around throughout the entirety of all our diagrams. There's one final step that I kind of like to do, and I'm going to add it here. I'm actually going to make this in green. This deals less to do with the actual covalent bonding and more to do with what we call molecular geometry. So it's kind of a step further. That is just where we separate. No, I'm not going to use the word separate. We space out our electron sets. And before you ask what's an electron set, that is going to be either a bond or a pair of electrons. So before we close out this video, we're going to do really 2 quick examples on how to actually utilize these steps. So I'm just going to move right over. If you needed that stuff, you can always pause the video. So example 1. I'm going to go ahead and bond oxygen to oxygen. So first things first, step 1 is draw our Lewis diagram. So I'm going to draw a Lewis diagram of each. Oxygen has 6 valence electrons like sulfur. So we have our lone electrons. We've got 1 lone, 2 lone, 1 lone, 2 lone. So we did step 2, we identified them. Step 3, we're going to go ahead and connect these. So I'm going to connect these using red just so we can keep things visually appealing. So each connection is a covalent bond, if we look at that, and each covalent bond is 2 shared electrons. So these oxygens are sharing a total of 4 electrons, 2 and 2. So step 4 is finally we're going to redraw these, but the atom with the most bonds is the central atom. They both have 2, so there's no center. And we're going to replace our lines with short straight ones. So what does this mean? Well, as we move to step 4, we are going to draw our oxygen and our oxygen. They have 2 bonds, so we're going to put 2 lines between them. Lastly, step C, we're going to add back electron pairs. 1, 2, 3, 4, 1, 2, 3, 4. There's our electron pairs. And this works. A couple things you may want to quickly ask is, was it okay if I drew it vertically or put the electrons on opposite ends? Absolutely, that's totally fine. I don't really care. Any chemist worth their salt will understand that these two are the same thing. Ooh, one quick thing I want to do is I just want to keep my colors consistent. So I will use red to denote the bonds. So that's the same thing. Step 4D. Well, we're going to do a quick little observation into that. If we look at our electron sets, I'm actually going to go ahead and just duplicate one of these real quick. Bring it over here and make it bigger. Let's go ahead and look at 4D. If we look at each electron set, we have 1, 2, 3 around 1 oxygen and 1, 2, 3 around another oxygen. The best way to divide anything into 3 separate parts is thirds. So what I'm actually going to do is redraw this as oxygen right there, and then the electrons, I'll kind of move to these weird angles where if I were to draw a line between each electron set, you'll notice that they kind of form thirds. Drew a little too far on that one. And that keeps all our electrons as far away as possible. And the reason for this is electrons repel each other. All right, so that's how you do a pretty simple example. I'm going to quickly give us a harder example. Example 2. We're going to look at hydrogen, carbon, and nitrogen. So I'm going to quickly draw these structures. 1, 1, 2, 3, 4, 1, 2, 3, 4, 5. So the best way to do this is, again, we're going to connect the dots. I can identify my lone electrons. So I'll go ahead and now connect these. And then I will redraw it. Now we have an atom with 4 bonds, which is the most. So carbon's going to be in the center, 1 bond to hydrogen, and 1, 2, 3 bonds to nitrogen. I'm going to go ahead and put my dots right there. We are done. So if you couldn't follow along, try it again a little slower, take whatever notes you need, and I hope you have a great night. Bye.